6.1, number 56. Motion with constant acceleration, the standard equation for the position S of a body moving with a constant acceleration A along a coordinate line is that. Okay, derive this equation by setting up and solving an initial value problem. Okay, so they tell us the answer. A over 2t squared plus v sub 0 t plus s sub 0. So our job is to derive that. All right, so we'll especially do more of this in Calc 2. And some of you might be with me for Calc 2. Most of you will not. And some of you may not even take Calc 2, which is really too bad. All right. So all we need to know is acceleration is acceleration. That's a good starting point. So if I know a of t is a, you can find the antiderivative of it. So antiderivative of acceleration would be velocity. So v of t, and the antiderivative of a, well, that's just a constant, so it would be at plus c, right? So if I know the acceleration is some number, a, the antiderivative would be at plus c. Well, we could be more specific what our c is, because that's really just our initial velocity right there. Like when time is velocity. If I put 0 in for time, that's going to be our velocity. So this right here is actually v sub 0. So we can say v of t equals at plus v sub 0, initial velocity. Going one step further, because we are trying to find s, or the position, we'd find the antiderivative again. The antiderivative of velocity is position. Remember, a is a constant, so the antiderivative of at would be a over 2t squared. Antiderivative of v sub 0 would be, that's just a constant, so v sub 0 t plus c. And we could be more specific with our c here with, we'll call it s sub 0, our initial position. When time is 0, this is whatever that constant is at the end. It's going to be, we derived it. So if you want to know the position of a particle at a point, then you can figure that out just based off of whatever the acceleration constant is. We'll talk much more about that stuff in the future.